Hello, this video is entitled The Ultimate Stoichiometry Problem because it goes over a large chunk of what you're going to need to know for the stoichiometry test. Alright, so the question is write and balance a neutralization reaction between sodium hydroxide and sulfuric acid. So we got to go back to the naming unit, naming acids, and then naming compounds. We got sodium hydroxide, that's on my polyatomic ion sheet, it's an OH. With a 1 minus charge, sodium's a 1 plus, that's balanced. And then sulfuric acid. So if it has an ICE ending, that would suggest it originally was an 8. If it had an OUS ending, that would mean the ending was an ite. So this is sulfuric, so it's going to have ATE ending, that's sulfate. Our polyatomic ion sheet says it's SO4 2 minus. And it's an acid, so it has to start with H. H is plus 1, and we need to crisscross it to balance it out. H2SO4. Alright, and then with a neutralization reaction, I know it's neutralization because I've got an acid, I've got a base, or you could call it a double replacement reaction where the H and the Na switch spots. It's going to give me H2O plus, so my H2O of my acid, my OH, my base forms the H2O, plus whatever's left over, NaSO4. SO4 is 2 minus, and sodium is 1 plus. We crisscross it. We got Na2SO4. Now it looks as though my H2O should have been an H3O, but the way I have it is correct. It is water, but now I have to fix it by adding coefficients, balancing it. I've got 1 sodium, 2 sodiums. I'm going to need a 2 right there, and then that gives me 1 SO4, 1 SO4. 2 oxygens, I'm going to put a 2 oxygens, 2 times 2 is 4, 2 hydrogens, 2 is 4, and it's balanced. Alright, that's part A. Part B, if 45 grams of sodium hydroxide reaction with 65 grams of sulfuric acid, what is the limiting reactant, or reagent? So in this case I have 2 givens. In basic stoichiometry, they just give me 1 given. I convert to moles, do my mole-mole ratio, and get my answer, but this is a little more challenging. They have 2 givens. So I'm just going to do the same thing, but I'm going to have 2 separate problems. 45.0 grams of NaOH, and I've got 65.0 grams of H2SO4. Alright, go into my little stoichiometry buddy sheet, write and balance equation, I just did that. Write down given information, I just did that. And now I need to convert to moles. So I'm going to put 1 mole on top and the molar mass on the bottom, which is 40 grams because the atomic mass of sodium is 23. Oxygen is 16 and hydrogen is 1. How do you know that? Well, you open up your periodic table or you pull that out and you look and find that the atomic masses for each one. 40 grams. Oh man, looks like we're going to have to do some math. Whenever we do math, we need to pull our calculator out. Good thing I kept mine in my backpack, which I brought to class. Sometimes I just put it in my pocket if I don't have a backpack. Alright, 45 divided by 40. Gives me 1.125 moles of NaOH. Alright, that's my convert to moles. All I did was convert to moles. Now I do step 4, which is mole to mole ratio. Alright, mole to mole ratio. I'm trying to find my limiting reactant. I could use water. I could use sodium sulfate. Doesn't matter. You just pick one, but then be consistent and choose that one for each of your problems. Alright. So I'm going to pick water because it seems to be fun. 2 moles of H2O over 2 moles of NaOH. Where did I get those 2 over 2 from? I get it from my coefficients in my balanced equation. 2 waters for every 2 NaOHs. And that's going to give me the same number but different unit. 1.125 moles of water. That's how much should be produced if I have 45 grams of NaOH. It's completely reactive. But I got to do the other one and see if it produces less water. If it does, then that would be my limiting reactant. Alright, we got 1 mole over 98 grams. Let's double check. 16 times 4 for oxygen is 64 plus 32 plus the 2 hydrogens. Why don't we just type that in our calculator just to be sure. 64 plus 32.1 plus 2 is 98.1. So I was off by a tenth. 65 divided by 98.1 gives me 0.66. Well, let's do 3 sigs on that one. 0.663 moles of H2SO4. And we want to do a mole ratio. 2 moles of water. We're going to pick water again because we did water on the top. We want some comparison here. And we're getting rid of sulfuric acid. No, this one's a little more challenging. So we're going to have to multiply it by 2. Multiply it by 2. 1.33. 1.33 moles of H2 is produced, which is more than the 1.1. So my limiting reactant would be NaOH. Just for fun, why don't we solve that same problem a different way? I found moles of NaOH. I found moles of H2SO4. I'm going to pick NaOH as reactant 1. Alright, so I've got 1.125 moles of NaOH, and I'm going to multiply this guy by reactant 2 and divide by reactant 1. So mole ratio. So reactant 2, looking at it, was the mole ratio comes from my balanced equation. So I said NaOH was reactant 1, this guy's reactant 2. I only have 1 mole of reactant 2, but I have 2 moles of reactant 1. 1.125 divided by 2 gives me 0.563. So 0.563 moles of H2SO4, that's how much I need. And I then compare it to how much I actually have, which was 0.663 moles of H2SO4. So this is what I have. Where did I get that number? Got it from here. Convert it to moles. I need 0.56. I have 0.66. Do I have enough? The answer is yes. I have more than enough. If I have more than enough, then H2SO4 would end up being the stuff that's left over, which is my excess. So H2SO4 is my excess. Therefore, NaOH is my limiting, which is how I found it to be doing it the other way. So 2 ways to find the same answer, limiting reactant. Okay, 2 down, 3 more to go in this ultimate quest of stoichiometry. What is the theoretical yield of sodium sulfate that would be produced? Alright, theoretical yield, we pretty much already did that, although the trouble is we looked for water. We used our limiting reactant, we found water, but this question is looking for sodium sulfate. Bad luck of the draw. Looks like we're going to have to do a stoichiometry problem, because we haven't done this one yet. We start with our limiting reactant. Convert it to moles. We did that already. It's 1.125 moles of NaOH. Step 4, which is mole-mole ratio. And we want to find sodium sulfate. So Na2SO4, and there's just 1. And we're getting rid of NaOH. And there's 2 of those guys. Alright, 1.125 times 1 divided by 2 moles of NaOH cancels out. And it looks like it's going to be 0.563 moles of Na2SO4 is produced. Alright, that wasn't too bad. Next problem, D. If you actually produce 5.4 grams of sodium sulfate, what is the percent yield? Now remember, percent yield is actual over theoretical times 100 to put in percent. And in this case, you can do 5.4 grams of your actual divided by your grams of theoretical, or you could do moles of your actual divided by your theoretical. It's your choice. We have moles of theoretical, we have grams of actual. We can either convert both grams or both the moles. I'm just going to convert both the grams. We got moles of Na2SO4 times this by the molar mass over 1 mole. We've got 23 is the atomic mass of sodium, but there's 2 of them, plus 32.1 for sulfur, plus 16 times 4 for oxygen, which would be 64. Alright, 2 times 23 is 46, plus 32.1 plus 64 is 142.1. Times it by 0.563 gives me 80. 80.0 grams of Na2SO4 is my theoretical. I'm going to take 5.4 grams that actually formed and divided by my theoretical, times it by 100. 5.4 divided by 80 times 100 gives me 6.75. As my percent yield, it's a very small percent, but it happens. Alright, now we have the last one, E. This is usually the most challenging. If you can get this, then the rest of stoichiometry is no problem, and you'll get an A on the test. How many grams of excess reactant remain? Okay, so we got to start with our limiting reactant. You start all stoichiometry with a limiting reactant. And I'm going to have to go through this a little quick because I have a 15-minute limit, and this has been a long video. Alright, limiting reactant we said was 45 grams of NaOH, converted to the moles, 1.125. 1.125 moles of NaOH. We're going to do a mole-mole ratio of reactant over reactant. Excess reactant over limiting reactant. Mole over mole. Our limiting reactant was NaOH. That's on the bottom. Our excess reactant is H2SO4. So we're going to put that on top. We've got a 1 over 2 ratio from the balanced equation. 1.125 times 1 divided by 2. NaOH cancels out. That's going to give me 0.563 moles of H2SO4 used up. That is all used up because 1.125 moles is our limiting reactant. That's all used up. According to our ratio, 0.563 moles of H2SO4 would also have to be used up. So now we go with how much we actually started with. Well, 65 grams, we converted that to moles. 0.663. 0.663 moles of H2SO4 is what we started with. We minus how much was used up. Minus 0.563. Alright, we take our calculator. 0.663 minus 0.563 gives you 0.1. 0.1 moles of H2SO4 is how much is left over. However, it asks us for grams, so we're going to take this 0.1 moles of H2SO4, multiply it by our 98.1 grams per 1 mole. Moles cancels out. And we're going to get 9.81 grams of H2SO4 is sitting left over. That is our final answer, and that is the ultimate stoichiometry.